Hi, I'm Brendan Burns from Microsoft Azure, and I'm going to talk about how volumes and storage work in Kubernetes. Obviously, in Kubernetes, the base unit is a pod. And within that pod can be one or more containers. But if you want to start talking about storage, you're starting to talk about volumes. And a volume is a separate object defined within the context of the Kubernetes pod. The volume is associated with the pod, but then mounted into a container at a particular path. And it can actually be mounted into one of the other containers in that pod at a different path. Or you might choose not to mount it into that container at all. In Kubernetes, there's a really wide variety of different volume implementations. From the simplest volume, which is a temporary volume that's associated with the pod. It's called emptyDir. Where the lifespan of this volume is associated with the pod itself. And the directory itself is simply present on the machine where the pod is located. So really just for caching and temporary information, maybe coordination between different containers in the application. All the way through cloud-mounted directories that are persistent across the lifespan of multiple pods, possibly even multiple clusters. So how does all that fit together? Well, in Kubernetes, beyond emptyDir and host path and other volume types that are associated with the cluster itself, there's this idea of a persistent volume. And a persistent volume is another resource type within Kubernetes. And a persistent volume can be mapped to something like Azure Disk or NFS, iSCSI, or any number of other sort of persistent volume types. The important distinction here is that these kinds of disks live longer than the lifespan of the pod. When the pod dies, if it changes machines, these disks will follow it around. So for example, if I have, this is machine 1, this is machine 2, and I have a pod running on that machine, it has a volume that is attached to that pod. If this machine happens to fail, and this pod moves onto machine 2, the volume will likewise move onto machine 2. But when you combine this sort of persistent volume with replication, things get a little bit complicated because the replica spec in a replica set or in a deployment has to have information about the volume. But obviously, you can't. Each volume is different. Each volume is independent. So you can't define all of the volumes in the context of a replica set. So in order to do that, Kubernetes introduces this idea of a persistent volume claim. And the idea behind a persistent volume claim is that it is responsible for saying, hey, you know what? I want aspirationally something like 10 gigabytes of disk. It's not a literal disk that is backed. It's more of an assertion of a need for a disk. So this way I can say, I want 3 pods. They all have a persistent volume claim that requests 10 gigabytes of disk. And when Kubernetes sees that, it's going to create those pods, obviously. But it's also going to create 3 independent persistent volumes and mount those disks into the container. Now, the good thing about this is not only does this provide for this kind of replication, but also the persistent volume claim and persistent volume become an abstraction between you and a cloud-based storage system, or really between you and any storage system. And so this persistent volume claim on different clusters, in one cluster could be satisfied perhaps by Azure Disk. In another cluster, it might be satisfied by iSCSI. And in another cluster, it might even be satisfied by another public cloud provider's disk product. So you can write a template that will operate across clouds, even across public cloud and private cloud, or even onto an on-prem environment where maybe this is being provided by network attached storage. It's a real way that you can use the same template across a wide variety of hybrid environments. And again, when you create a persistent volume claim, much like the rest of Kubernetes, you're declaring what you need rather than the specifics of how you implement it. And you're allowing the cluster's automation to take responsibility for providing the disks to you. Hopefully that gives you a little bit of an illustration of how persistent volumes and storage work inside of Kubernetes.